Okay, hello students. We'll continue chapter 14 normalization, and we reach to identify how to identify the functional dependency. So if we have this relation, for example, employees with the following attributes: SSN, name, years of employment, the salary, and the bonus. So we can get the functional dependencies by assertions like this one. If we have this sentence, employees hired the same year have the same salary. So all employees that are hired at the same year should have the same salary. This means that the years of employment determines the salary. So this assertion implies the years of employment for this employee determines his salary. So this is the first way to determine functional dependency, by using assertions in sentences. We have other ways or inference rules. There are 6 or 7 actually. We have the first inference rule, named the reflexive rule. This means if we have a functional dependency x determines y, then y is a subset of x, or if y is a subset of x, then we can say that x determines y. For example, SSN determines the SSN because the right side, which is SSN, is subset of SSN. Another example, we have P, S, and the quantity determines the quantity because quantity is subset of this one. So if you have a functional dependency, then the right side should be, or maybe, a subset of the left side by the reflexive rule. Other way, or another inference rule we have, is the augmentation rule, which tells us if we have this as an initial functional dependency, which is x determines y, then we can add another attribute z here and z here. So it becomes xz determines the yz. So the functional dependency xz determines yz is logically implied by this one. So for example, if we have this initial set of functional dependency, the SSN determines the address, then this functional dependency is logically implied by this one. We add name to the SSN and we add name to the address, then it becomes SSN plus name determines the address name. So this is the second inference rule for finding functional dependency, is augmentation rule, by adding an attribute to the left side of the functional dependency and adding the same attribute to the right side of the functional dependency. It remains a functional dependency. The first one, if we have y, which is a set of attributes that is a subset from x, which is another set of attributes, then we can say that x, which is on the right side, determines y. The third inference rule is the transitive rule, which says that if x determines y and y determines z, then x determines z. Because y is in the middle, x determines y, and y determines z, then x determines z. So for example, if we have this initial set of functional dependency, the SSN determines the department number, and the department number derives or determines the name, the department name. Then SSN determines the D name is logically implied by F, or you can get this one out of this one by using a transitive rule. The inference rule 4 is the decomposition rule, which tells us if we have x determines y and z, then we can decompose the right side into single attributes, which gives us x determines y and x determines z. For example, if we have SSN determines e-name, birth date, address, and the department number, then we can write SSN determines the e-name, and SSN determines the birth date, and SSN determines the address, and SSN determines the department number by using the composition rule. We have the union rule, which is the contrast for this one. If we have X determines Y and X determines Z, then we can say that X determines Y and Z. So X determines Y and X determines Z, then we can write X determines Y and Z. For example, if we have SSN determines the e-name and SSN determines the birth date, then we can write SSN determines the e-name and the birth date. This is by the union or rule, union or additive rule. We have also the pseudo-transitive rule, which tells us if we have X determines the Y and W, Y determines Z, then we can say that W, X determines Z. X, if we have X determines the Y and this Y, and we have WY determines Z, then we can change this Y to X and write WX determines Z. For example, if we have SSN determines the student number and SSN determines the major, if we have SSN determines the student number, this is the first functional dependency, and the second one, major and the student number determines the name. Notice here we have student number in the right side of SSN, and we have student number beside the W, which is major. Then we can write SSN plus the we can write the major plus SSN determines the name by using the pseudo-transitive rule. So SSN determines the student number, which is X determines the Y, and we have WY determines Z, which is major plus student number determines Z, which is the name. Then we can write the major, which is W, plus X, which is SSN, determines Z, which is the name. Okay, we'll continue in the next video talking about the closure of attributes. Thank you for watching.